Hi guys, welcome back to another video in the series of videos about Chapter 5 Forces in Motion. In the previous video we talked about the concept of acceleration. If you have not yet seen that video, I would suggest you do that now. You can use the link that pops up right about now. Alright, still around? In this video I will teach you how to calculate the acceleration in two different ways. And finally, you will also learn how you can determine the distance traveled using a velocity time graph. Like before, let's review today's learning goals. After this lesson, you will be able to calculate an object's acceleration using a formula, determine the acceleration from a velocity time graph, and last but not least, determine the distance traveled from a velocity time graph. Let's start with the first one, calculating the acceleration using a formula. Suppose you're riding a train leaving the station. The velocity would increase until at a certain moment its speed remains constant. In this example, the train accelerates between t equals 0 and t equals 7 seconds. From t equals 7 seconds, the velocity is constant. That means that the acceleration is equal to 0. Please note that the gradient of the velocity time graph is 0 as well at that point. So, how do you calculate the acceleration of the train? Since acceleration is the speed increase or decrease per time unit, you can calculate it by dividing the speed increase by the time interval, or time duration, or using a formula. The acceleration a equals the change in velocity divided by the difference in time. Alternatively, the acceleration equals delta v divided by delta t, where delta indicates the change in velocity or time. An important thing to remember is that you should always use the standard units for velocity and time. Let's have a look at a worked example. In this worked example, we'll have another look at our train. We want to calculate the train's acceleration as it leaves the station. As you can see, the speed increases from 0 to 60 km per hour in just 7 seconds. Now let's calculate the train's acceleration using the formula I just told you about. Gathering all the relevant data gives us the following. The initial velocity is equal to 0, the final velocity is equal to 60 km per hour, and the time interval is equal to 7 seconds. This means that the change in velocity is equal to 60 minus 0, which is 60 km per hour. But remember, you should always use the standard units for velocity and time. That means that you should convert kilometers per hour to meters per second. Last year, you learned that you should divide the number by 3.6 to go from kilometers per hour to meters per second. In this case, that means that the increase in velocity is equal to 16.7 meters per second. Now we can calculate the acceleration using this formula. Delta v is equal to 16.7 and delta t equals 7. Using those numbers gives us 2.4 meters per second squared. Not too difficult, right? The most tricky step is probably the conversion from kilometers per hour to meters per second. Make sure you remember to always convert the units to meters and seconds. Okay, let's take a look at another way of determining the acceleration. When you have a velocity time graph, you can also determine the gradient, which will give you the acceleration as well. Remember, your maths teacher has taught you that the gradient is the change in y divided by the change in x. In our case, that means that the gradient is the change in velocity divided by the change in time. The change in velocity is 60 minus 0, which is 60 kilometers per hour. But remember, we should always convert that to meters per second. And that means that the change in velocity is also 16.7 meters per second. Now we can calculate the gradient as follows. The gradient is 16.7 minus 0 divided by 7, which again equals 2.4 meters per second squared, as it should. Now there's one more thing I have to explain. When you have a velocity time graph, you can also figure out the distance traveled. In a velocity time graph, the distance traveled is the surface area underneath the graph. So, the distance traveled in the first 7 seconds is equal to the surface area of this triangle. Again, your maths teacher will have taught you how to calculate the area of a triangle, which is the base times the height times 1/2. In our case, that means that the area of this triangle is equal to 1/2 times 16.7 times 7, which results in a distance traveled of 58 meters, which has been rounded off. And that's it. Now you know how to calculate the acceleration using this formula. You know how to determine the acceleration by way of the gradient in a velocity time graph, and also how to determine the distance traveled by calculating the area underneath the graph in a velocity time graph. And that brings us to the end of another video. Make sure you tune in next time, because in the next video you will learn about the force. No, not that force. I'm talking about the so-called resultant force and its effect on the acceleration. See you next time.